My name is Mary Gamberg. I am a research scientist based in Whitehorse in the Yukon. Plastics are emerging as a contaminant of concern, and they have been designated as such under the Northern Contaminants Program. For a few years, we have been measuring microplastics in the stomachs of animals. And when I say animals, I mean actually marine mammals and fish. And we realized that it's not necessarily the best way to measure the effects of plastics on animals because really you just get an indication of the last meal of the animal. Um, I just finished a collaborative project looking at plastics, microplastics in walrus from Nunavut. And there were no microplastics in their stomachs, but honestly, their stomachs were empty, so it was not surprising. What we do know is that plastics plastics themselves, like the plastic polymer, is not toxic. However, there are a multitude of different chemicals that are added to that plastic polymer to give a particular plastic particular physical characteristics. So the things that make it into a filmy plastic, like you would put over your food, or a hard plastic that you might find in your computer or a snow shovel. There are all different kinds of plastics with different characteristics. And those chemicals that are added to the plastic polymers can be toxic and they can come off the plastic polymer in the stomach of the animal and be absorbed into the animal's body. So, what we have moved to now is instead of measuring microplastics in stomachs, we're measuring plastic additives in the tissue of the animal. So, the muscle and the liver, I think, are the target tissues. And to date, people have done this work in fish, where we definitely find plastic additives. And in the walruses that I just mentioned in Nunavut, we did plastic additives with them as well. And there are for sure plastic additives in those animals. And these guys are in very pristine environments in the high Arctic, and still they have evidence of plastic pollution. They have plastic additives in their tissues. The the availability of those plastics in the ocean is huge. I'm sure we've all seen the huge Pacific plastic patch that's, enormous. There are a lot of plastics in the ocean. They get broken down from macroplastics to microplastics, and now we're realizing nanoplastics. So it's very available in the ocean. There has been work done on marine mammals. There is currently work being done on fish. To my knowledge, terrestrial animals have not been measured for plastic additives. So this is the first year that we are going to do that with the caribou. We're going to measure plastic additives in their muscle and their liver. So we're doing it as part of our regular project, collecting samples the way we normally do, and those samples will be analyzed for the normal range of contaminants. And in addition, we will do the plastic additives. In addition to the plastic additives, and this is all kind of cutting edge stuff, which is kind of exciting. In addition to the additives, there is a machine being designed and produced that can measure nanoparticles of plastic, which are 1,000 times smaller than the microplastics. These are so small that they can be absorbed into the blood and be distributed around your body. So we probably have nanoplastics. All of the plastics that have ever been produced on the earth, unless they've been burned, which is not a good thing to do to plastics, but other than that, all of the plastics that have ever been produced on the planet are still here. They just get broken down into smaller and smaller and smaller pieces. So there are a lot of nanoplastics around, like a lot. And this new machine is going to be one of them is going to be bought by Environment Canada in Ottawa, and they are going to measure ultra fine particles, the nanoparticles, in the caribou tissue as well. So we'll be doing the plastic additives and actually also the plastic polymers in the caribou. I would expect caribou to have lower levels of of plastic additives than marine mammals and lower than fish. I'm not sure that that's going to be true. It depends on how much atmospheric transport of nanoparticles of plastic there is. And this is something that we just don't know about yet. And if there is a lot of atmospheric transport of nanoparticles that are taken up by caribou through lichens, then it could be higher than we anticipate. We'll see.